Hello everyone, and welcome today to my Pure Math YouTube video. So today I'll be ending trigonometry with products as sums and differences, and sums and differences as products. So first of all, what do I mean by a product as a sum or difference? So the product to sum and difference, or sum to product identities, they're trigonometric identities that allow us to convert products of trigonometric functions into sums or differences of trigonometric functions. So what does this mean? So it means that we can convert something like sine a plus b and sine a minus b. We can put those together. We can add those together or subtract them together or subtract them to get something else. And that's exactly what these identities are. So why would we use these? Well, we use these identities when we want to solve a trigonometric equation or simplifying a trigonometric expression. So earlier I said that you could add these, right? So sum to difference or difference to sum, you could add these. Well, how would you do this? So if you wanted to add sine a plus b to sine a minus b, well, first let's just expand it. So we know from my previous video in well, I don't remember the exact video, but I'll link it in one of my previous videos in trigonometry, that the expansion of sine a plus b is sine a cos b plus cos a sine b. And we know that the expansion of sine a minus b is going to be sine a cos b minus cos a sine b. Now if I have both of these and I added them, well, I'll put the addition sign over here. Well, what would I get? So sine a cos b plus sine a cos b is the same thing as 2 sine a cos b. And cos a, we're going over here now, cos a sine b minus cos a sine b is the same thing as saying nothing. So this cancels out. So we have our very first identity. So when we add these two, when we add the expansion of sine a plus b and sine a minus b, we get our very first product from sums and differences. Well, in this case is from sums, and we got it from adding the expansion of sine a plus b and sine a minus b. So this is the first one. So you want to just write this down, take note of it, and yeah. So let's do another one. So let's say we have sine a plus b and sine a minus b. So again, we'll expand these. Expanding this, we'll get sine a. Again, this is always a good practice because it's always good to keep doing these things so that they stick in your head. And over here is again sine a cos b minus cos a sine b. Now, in the first one we added them, but for this one, what if we had sine of a plus b minus sine of a minus b? So in the other one, we would have, this would have plus, but in this one, we just have minus. So let's subtract them and see what happens. So if we were to subtract these two, what would we get? I'll just throw this thing over here so it doesn't bother us. So if I wanted to subtract these two, what would I get? I'm going to remove this equal sign. Subtract them. So we have sine a cos b minus sine a cos b. This cancels out. And cos a sine b minus cos a sine b. We remember cos a sine b minus cos a sine b. That's what we're doing. And that's going to give us, what would that give us? That will give us plus, because a negative and negative gives positive. So this is going to give us 2 cos a sine b. And, well, this is your very second one. You've just derived 2 of them. Just from knowing these trigonometric expansions, you're able to form more, and it really depends on your root understanding of how sine is expanded. And once you can do that and you understand how to add things, well, I think you'll be pretty good. So this is for sine. Well, what if we had cos? So let's say you had cos of a plus b, and you had cos of a minus b. So that's going to be equal to what? So if you expand this, you're going to get cos a, cos b, minus, remember, the sign in the bracket should always be opposite to the sign used, minus sine a, sine b. And for cos a minus b, well, that's just going to be the same thing but with different signs, plus sine a, sine b. And let's say we wanted to have cos a plus b plus cos of a minus b. Well, that would be equal to adding equation 1, which is this one up here, to equation 2, which is this one down here. So to do that, we just add them, and if you add them, you'll see minus sine a plus minus sine a sine b plus sine a sine b would cancel out, so that would cancel out and give us nothing right here. And then over on this side now, cos a cos b plus cos a cos b. Well, what would that be equal to? Well, it's just going to be equal to 2 cos a cos b. And again, this is another one of our products, or for sums, products as sums and differences. Well, this one's a product of sum as a sum. Well, this is a, yeah, product as a sum, okay. Yeah, so this is going to be our third equation that we have found out. And now, what if we wanted to have cos of a plus b minus cos of a minus b? Well, going back up here, what would we have? Instead of having actually I think I'm going to just, yeah, actually no, it's fine. Instead of having a plus sign here, we're going to have a minus sign here, so it's going to be subtracting. And then if we just expand this, we'll have cos a cos b minus cos a cos b, so we know this term cancels out. And then we have minus sine a sine b minus sine a sine b. And when you have a minus and a minus, it's just going to continue being minus because we're not multiplying. So we'll have minus sine a sine b minus sine a sine b, which is just simply going to be equal to minus 2 sine a sine b. Okay? So this is going to be our fourth equation that you should remember. Please write these down because we're going to be doing some practice problems with them now. And you'll get to see how they're actually used. So good job. That's the first section of understanding this whole thing. You just have to know those four things first. So again, just to go over, what I'm going to do is I'm just going to write them down, all formulas. Oops, yeah. So to write all the formulas, I'm just going to write them down quickly. I could probably speed this section up. So we'll have 2 sine a Okay, we're back. So now we have all formulas written here. And so now that we have all the formulas, well, you can take a screenshot, you can pause the video, write them down at your own leisure. And we'll be starting some questions right now. So let's say a question asked us to convert, cos 7 theta cos 4 theta to a sum of terms, to a sum. So look what we have here. So we have two cos terms being multiplied. This means that the result of this is going to be a product. And remember, this whole video is about products to sums and differences. So when you look at this, cos A, cos B, well, does that remind you of anything? So if you look up here, where both the terms are cos, well, there's only one equation where both of them are cos, and it's this one right here. So since this mimics the form cos A cos B, we could say, right, and just stay with me here, I'll explain everything in a little bit more detail, like where the 2 is going to go away, like how the 2 is going to go, but you'll see. So using that, we know that for cosine of A cos B, when they're being multiplied, the product of that is equal to the sum of 2 cos A cos B is equal to cos A plus B plus cos A minus B. And in this case, they give us A, we can just let A be equal to 7 theta, and B we'll say it's equal to 4 theta. So knowing this, we can actually substitute this in. So what we can do is we can have 2 cos 7 theta cos 4 theta is equal to cos of A plus B, which is 7 plus 4, which we know is going to be, I'll just write down 7 theta plus 4 theta plus, cos of A, where A is 70, so it's going to be 7 theta minus 4 theta. Sorry, the theta looks kind of like 0, so I thought it was 70 for a second. But nevertheless, let's continue. So simplifying this now, on the right hand side we have cos 7 theta plus 4 theta. So that can just be written as cos of, what's that, 11 theta plus cos, and on this side we have 7 theta minus 4 theta. So in this case we can have cos of 3 theta. So we have 2 cos 7 theta cos 4 theta is equal to that. But pay attention, the question gave us cos 7 theta cos 4 theta. The question did not say anything about 2 cos 7 theta cos 4 theta. So to get it back to express this as a true form of the sum of terms, we have to get rid of the 2. So to get rid of the 2, we just divide both sides by 2. And so we will get that cos 7 theta cos 4 theta is equal to a half of cos 11 theta plus cos 3 theta. And that is it. That's all the question asks you to do. And so that was fairly straightforward, I believe. The hardest part was actually remembering the product as a sum and difference. So let's try something else. Okay, so let's go. What if a question asked us to do, well, it asked us to express, so express 2 sine theta cos 3 theta as a sum or difference. Now, immediately what you should be looking at in this product, because remember, these two things are being multiplied together, so they are a product, is what do you have? So you have sine and you have cos. So what you're going to want to do is try to remember, but do you remember any of the products as a sum or difference that use sine and cos? Well, if you don't remember, I'm going to be slowly going up. So we want something that has sine and cos. So we're looking at the bottom one. This has 2 sines, so that's out. The second to last one has 2 cos's, so that's out. Well, I don't know if cos is a word, but it has 2 cos, so that's out. The third one has cos and sine, but not in the order that we want it. We want it in the order of sine and then cos. And the first one has sine and then cos. So we know that we'll be using this identity up here. Or not identity, but yeah, you get what I mean. So remembering that one, we would get, well, I'll just rewrite it. So let's say we have 2 sine A sine B is going to be equal to sine of A plus B plus sine of A minus B. And in this case, they gave us A equals theta and b equals 3 theta. Where do I get this? I get this from what they gave us right here. So they gave us a as the first term being theta and b as the second term being 3 theta. So that's how that is. So now let's substitute in our values for a and b. So substituting now, we'll get 2 sine theta I made a mistake. So what should have been there is 2 sine A cos B instead of 2 sine A sine B. So sorry for the error. 2 sine theta times cos of 3 theta should be equal to sine of theta plus 3 theta plus sine of theta minus 3 theta. So if we were to work this out a bit more, what we'd get is sine of 4 theta, because theta plus 3 theta is just 4 theta, plus sine of minus 2 theta. So what you want to remember here is if you have sine of minus, minus theta, it's the same thing as saying minus sine of theta. So in this case where we have sine of minus 2 theta, this is actually going to just be the same thing as minus sine of 2 theta. So we'll have sine of 4 theta minus sine of 2 theta. And so we'll just rewrite what we had before. So using the thing that they gave us in the question, they wanted us to express this up here as a sum or difference. So we'll rewrite this and say it's equal to what we just worked out. So they gave us 2 sine theta cos 3 theta is equal to sine 4 theta minus sine 2 theta. And great, now that's going pretty well. You guys are doing pretty well, hopefully. So we're going to be continuing now. What if a question asked us to express? Well, they wanted us to express, we'll say 8 cos 2 theta times cos of theta as a sum or difference, as a sum or diff. So to do this immediately, what we should automatically be looking at now is how many sines and cos, sines and cos, how many versions of, how many sine and, how, are there, okay, is there a sine and is there a cos? All we should be looking at. So right now we see that there are 2 cos, right? So there are 2 cos's in the mix. We can just look up here and look for the one that has 2 cos. So we have 2 cos A cos B is equal to cos A plus B plus cos A minus B. So let's go. So we know that 2 cos A cos B is equal to cos A plus B plus cos A minus B. And in this case, they gave us A is equal to 2 theta and B is equal to theta. So substituting these in, we'll have 2 cos of 2 theta cos of theta is equal to cos of 2 theta plus cos of 2 theta minus theta. So simplifying this, we'll get this equal to cos of 3 theta plus cos of theta. So we have 2 cos 2 theta cos theta equals that. Now what did the question ask us? Well, the question asked us to express 8 cos 2 theta cos theta as a sum or difference of 2 terms. So how do we do that? So we have 2 cos of 2 theta. We do not have 8. So what we can do, how could we make 2 into 8? So if you multiply both sides by 4, well, we can get 4 times 2 is 8. So we'll have 8 cos 2 theta. Cos of theta is equal to, when expanding, remember to give this 4 to each term, 4 cos of 3 theta plus 4 cos theta. And that is precisely how you do that question. So you can take a moment to try to just get what I'm saying. And yeah, we will be continuing with another section of this video now, and this part is converting sums and differences to products. So I'll just write a little heading here in blue, converting sums and differences to products. Great. So I shortened everything just because in the middle of a video you don't want to be watching me write that. So I'll be showing you what these formulas are, and then we'll be able to use them in a couple questions. So if we have sine A plus sine B, well, this is going to be equal to, so we're going to try to convert this sum into a product. So how we do this is in fact, well, I'm going to give you the formula, but the formula itself is sine A plus sine B is going to be equal to 2 sine of A plus B over 2 times cos of A minus B over 2. And that's converting this sum to this sum and difference to a product. So continuing, if I have, oh sorry, if yes, so continuing, if I was to have sine A minus sine B, I would instead have 2 cos of A plus B over 2 times sine A minus B over 2. These formulas is good to have them memorized, but they're also on the formula sheet that you should be given during the exam. But yeah, I think it's a good idea to always have them memorized, because if you see something in this form, if you see sine A plus B, you can automatically just put it in this form instantly, and you just remember you don't have to check the formula sheet and waste time or whatever. But this is for sine. So what if we were to have cos A plus cos B? Well, that's going to be equal to 2 cos of A plus B over 2 times cos of A minus B over 2. And that is one of the formulas for cosine. So if you ever see cos A plus cos B, where A and B are, it could be anything, it could be theta, cos 7 theta plus cos 3 theta, you could automatically transfer this into a product by using this little formula, or I guess you could call it, like, I wouldn't say it's a formula, but you could use that to convert it. So what if we have cos A minus cos B? Well, that's actually just going to be equal to minus 2 sine of A plus B over 2 times sine of A minus B over 2. And those are the 4 things that you need to know in this kind of chapter. So take a second and swat it, and then we're going to continue with some questions. Prove that sine of C plus sine D is equal to 2 sine of C plus D over 2 times cos of C minus D over 2. Well, how could we do that? So instantly we're going to look at the right hand side because it has more information, and if you notice, the right hand side is actually a product, and while we may not know how to convert properly from a sum to a product, we know how to convert from a product to a sum, because that's what the first half of this video was about. So if you remember, when it's 2 when it's sine and cos being multiplied, if you use this up here, look for sine and cos in that order, well, it's going to be 2 sine A cos B is equal to sine A plus B plus sine A minus B. So we can replace this product with that itself. So instead of having 2 sine C plus D over 2 times cos C minus D over 2, well, instead of that, what we can have is sine of A plus B plus sine of A minus B. And in this case, A is going to be equal to C plus D over 2, and B is going to be equal to C minus D over 2. So the hardest part here is getting used to having A to being multiple variables. So if you notice, what's inside this bracket here can all be categorized as A. Because if I just had A here, like, you'd instantly remember the formula. But that's too easy, so yeah. So instead, we're going to have C plus D over 2. So you just have to make A equals C plus D over 2, which it is. And now that you have that, that's actually the hardest part of this whole question. Well, you can just put it into the other form. So we know that sine A plus B plus sine A minus B should be equal to 2 sine C plus D over 2 times cos of C minus D over 2, right? So what if we just actually worked out this right here? So we just found out what A was and we found what B was. But in this bracket, A is being added to B. So what we're going to have is sine of A, which is C plus D over 2, plus B, which is C minus D over 2. And if you see where I'm getting this, because this is what we're using right here, A plus B. And then this will be added to sine of, so A in this case is C plus D over 2 minus, because it's subtracting it here, minus, so that's A minus B, which is C minus D over 2. Okay, so now all we have to do is work this out. So if you work out this one over here, if we work this one out, we'll have sine of, so if you have C plus C, that's 2C, and if you have D minus D, that's nothing. So you'll have 2C over 2 plus sine of, so if you have C plus C minus C is just, so C minus C cancels out, and you have D minus D, well, that's going to be D plus D, which is going to be equal to 2D. So sine 2D over 2, and this can just be simplified a little bit more, because we're going to, if you cancel out the 2's, we're going to have sine of C plus sine of D is going to be equal to, well, it's actually just equal to the left-hand side, which is what we're trying to prove this whole time. We're trying to prove that that is going to be equal to this, so we were able to prove that. And so that's how these things would be proved. You just have to be cerebral enough to realize that if you, the formula that you learned, this one over here, is actually just a product, and you just learned all the formulas for products, hopefully. So yeah, you should probably be able to understand how to do these now. Probably give it a try to prove the other ones on your own. If you're not able to do those, then you can always just type it in the comments and I'll try to do it myself. Well, I should be able to do it myself, and I'll just do it for you. And now we're going to go to a question. So let's say they want us to convert 9 sine of 9 theta plus sine of 6 theta to a product of terms, so to a product. Well, we know that sine A plus sine B is going to be equal to what? So if you remember that formula that I was showing earlier, this one down here, what do we have? Well, we have sine A plus sine B. So what is this going to be equal to as a product? Well, it's going to be equal to this, because we have sine A, sine B. is going to be equal to sine a plus b over 2 times cos a minus b over 2. So I'll just rewrite this here so that we can get it. It's going to be equal to 2 sine a plus b over 2 times cos of a minus b over 2. And in this case, we have a as equal to 9 theta and b equals 6 theta. So on the right hand side, continuing, we're going to have 2 times sine of a, which is 9 theta, plus b, which is 6 theta. So I'll just do this. It's going to be 15 theta over 2 times cos of a, which is 9 theta, minus 6 theta, which is going to be cos of 3 theta over 2. Okay? And well, that's essentially it. We just converted what we had before, sine 9 theta. So we have sine of 9 theta plus sine of 6 theta is going to be equal to 2 times sine of 15 theta over 2 times cos of 3 over 2 theta. And just like that, we have expressed this sum as a product of two terms. And that's great. So what if we try to do another one? And this will be the last one for the video because these are not that difficult and they come on the formula sheet. So yeah, that's always good. So cos of 7 theta plus cos of theta. They want us to convert this to a product of two terms. So we know that when it's cos A plus cos B, if we go down here again, look for cos A plus cos B, well, if you find it, you'll see it right here. It's going to be equal to 2 cos A plus B over 2 times cos A minus B over 2. So we can now go and work this out. So we know that cos A, because this mimics the form cos A plus cos B, is going to be equal to 2 times cos of A plus B over 2 times cos of A minus B over 2. And well, what can we do? Well, in this case, they gave us A is equal to 7 theta and B is equal to theta. So substituting that into this right here, we get 2 cos of A plus B, which is 7 theta plus theta is just 8 theta over 2 times cos of 7 theta minus theta is just 7 minus 1, which is 6 theta over 2. Now this is going to be equal to 2 times cos of 8 theta over 2 is just 4 theta, and multiplied by cos of 6 theta over 2, which is just 3 theta. So therefore, cos of 7 theta plus cos theta is going to be equal to 2 times cos of 4 theta times cos of 3 theta. And well, that's just about all you need to really know for this topic. Practice is obviously going to make you a lot better at this, and yeah, congratulations, you have essentially finished trigonometry with this playlist. Or if you just looked at this video standalone, that's pretty cool as well. Well, there's one slight thing that I've not added, and it's the general solution. I haven't added it yet because I actually don't really understand it myself. So once I understand that, I'll be able to give you a video where I explain things a lot more. So hopefully this video was helpful to you. If it was, you can feel free to subscribe and watch the rest of the playlist because I go through the entirety of Cape Pure Math Unit 1. Also, if you think my handwriting is getting better, thank you because I've actually been working on it. But yeah, that's all for this video, and thank you for watching. Goodbye.